significance level. We want to try our best when we conduct a hypothesis test to not make mistakes when we do our test. So what do I mean by that? Suppose we're trying to determine whether or not a coin is fair. Our null hypothesis would be that the coin is fair. You flip it and you get heads half the time, tails half the time usually. Now the alternative hypothesis would be the coin is unfair. You're more likely to get one thing versus the other. Now let's pretend like we flip the coin 20 times and it falls on heads all 20 times. If this happened, we would probably conclude the coin is unfair. What if, though, we're flipping a fair coin and all 20 times the fair coin lands on heads? Now, if this happened, we probably would conclude that the coin was unfair when actually it really was fair. This would be a mistake. It's a mistake because the coin was fair, but we concluded that it was not fair based on what happened. So we can't prevent mistakes like this from happening when we do a hypothesis test, but we want them to happen infrequently. The significance level is a number that we use to measure the likelihood of making a mistake when we conduct a hypothesis test. In particular, the significance level is the probability of making a mistake of rejecting the null hypothesis when in fact the null hypothesis is true. So in the experiment we're talking about with spinning the coin, the significance level is the probability that we will conclude that the coin we're spinning is not fair when in fact it really is fair, if we were to do a test and actually spin the coin a bunch of times and see what happened. We use a special notation for the significance level. In particular, we use this letter alpha. That's the lowercase Greek letter alpha. So I said that significance level is a probability, and probabilities, remember, are numbers between 0 and 1. And so we're going to have alphas that are a number between 0 and 1. Okay, let's look at an example. We are testing someone who claims to have ESP by having that person predict whether a coin will come up heads or tails. So ESP means you're like psychic. You can make a guess about something that's going to happen before it happens. Extrasensory perception. Okay, so the null hypothesis is that the person is guessing and does not have ESP. So they can't predict the future. Someone's going to flip a coin and they're going to guess if it's heads or tails, and they're going to guess wrong half the time and right half the time. So if the person doesn't have ESP, the population proportion of them correctly guessing if the coin is heads or tails is just going to be 0.50. We would expect they would guess correctly half the time. Now we test the claim with a hypothesis test using a significance level of 0.05. So in particular, we're going to have the person guess if they flip a head, if someone is flipping a heads or tails, and conduct a hypothesis test, which we'll learn how to do in 8.2, and we're going to use a significance level of 0.05. What does it mean to have a significance level of 0.05? That's the point of this problem. So we're going to write a sentence describing the significance level given the context to help you guys better understand what significance level is. So the significance level is the probability of rejecting the null hypothesis when in fact it's true. In other words, it's the probability of rejecting the claim that the person doesn't have ESP when in fact they don't have ESP. We're told the significance level is 0.05 or alpha is 0.05. This means that when we conduct our hypothesis test, the probability of concluding that a person has ESP when he or she does not is 0.05 or 5%. So if we conduct our test, the probability that we're going to make a mistake and conclude that a person has ESP when they actually don't is 5%. Significance level is a number that you choose, and so you're going to decide to do a hypothesis test, and you're going to pick a significance level that you want your test to have. And so the standard significance level is 0.05, but some people choose to use other numbers like 0.01 or 0.10. It depends on the field you're in and sort of like the study you're doing and a variety of factors, but standard is 0.05. Now, we're going to learn more about this in 8.2 when we actually conduct the tests. For now, you have some idea what it is.